What if I told you that you, this planet, and the most distant star you can possibly imagine, all playing by the exact same set of rules? Well, today, we're taking a quick tour of that rulebook, a beginner's guide to, well, everything.
And that's a fair question, right? The scale is it's mind-boggling. But there actually is a simple, kind of elegant starting point that connects it all, from the atoms inside your own body to the very heart of the most distant galaxy.
And that starting point is this. The entire universe, for all its chaos and complexity, plays by one single, unbreakable set of principles. We call them the laws of physics, but you can think of them as the fundamental operating system for reality itself.
This right here, this is the key that unlocks the whole cosmos. It doesn't matter if you're looking at a tiny subatomic particle or a galaxy-sized quasar, the same laws apply. It's the shared language of existence, and by learning that language, we can start to figure out our place in all of this.
So, let's kick things off with the objects that light up the darkness and literally forge the elements of existence, stars. They are the great cosmic engines, and believe me, they power everything.
At its core, a star is a really simple thing. Just picture a giant ball of gas, mostly hydrogen, so massive that its own gravity is trying to crush it into a single point. And it's that immense, relentless pressure from gravity that ignites the magic in its core.
And that magic is called nuclear fusion. It is the power source of the universe. So, here's how it works. First, gravity yanks those hydrogen atoms deep into the star's core. The pressure gets so intense that these atoms are literally forced to fuse together, creating a totally new element, helium. And here's the kicker. In that moment of creation, a flood of pure energy is released. So every single time you see a twinkling star, you're seeing the light from countless tiny atomic explosions, a cosmic engine burning across the void.
And that energy, it isn't just for show. It travels across the vastness of space. It warms planets just like ours, and it provides the essential power that life needs to even get started. I mean, without the steady, reliable fusion engine of our sun, we just wouldn't be here. Simple as that.
But here's the thing. Not all stars are created equal. Smaller stars, kind of like our sun, they're the marathon runners of the cosmos. They sip their fuel, shining steadily for billions and billions of years. But the giants, oh, they're the sprinters. They live fast and die young, burning through all their fuel in a spectacular cosmic flash that lasts just a few million years.
The birth of a star is a pretty messy process. And all the leftover gas, dust, and debris, it doesn't just float away. It becomes the building blocks for entirely new worlds.
Yeah, all that leftover cosmic rubble gets pulled together by the young star's gravity. It starts clumping and crashing together over millions of years, eventually forming planets. And this means that, in a very real way, every planet, including our own Earth, is literally made of stardust, the recycled leftovers of a star's birth. And the sheer variety of worlds out there is just staggering. You've got small, rocky planets like Earth and Mars, places with solid ground you could actually stand on. Then there are the colossal gas giants like Jupiter and Saturn, these enormous swirling worlds with no surface at all. These worlds can have their own families of moons and beautiful, intricate ring systems. And when you think about the billions of galaxies out there, well, the odds are pretty good that some of them might just have the right conditions for life.
But what happens at the end of a star's life? Well, for the most massive stars out there, their story ends with gravity winning its final, ultimate victory. So when one of those massive sprinter stars runs out of fuel, that outward push from fusion just stops. And with nothing holding it back, gravity wins. It takes over completely, crushing the star's core with just unimaginable force into an object so dense it's almost infinite, a black hole.
And this quote really says it all. The gravity becomes so intense that it creates a boundary, a point of no return, called the event horizon. Once you cross that line, there is no getting out. Not even light, the fastest thing in the entire universe, can escape its pull. And it turns out these aren't just rare oddities. Astronomers have found absolutely colossal versions, called supermassive black holes, sitting right at the heart of nearly every major galaxy, including our own Milky Way. They're like these central gravitational anchors that entire galaxies spin around. Okay, so we've got stars, planets, and black holes. But what do they all exist in?
To get that, we have to talk about the very fabric of reality itself.
So we're used to thinking about space, up slash down, left slash right, forward slash back, as being totally separate from the forward march of time. But Einstein showed us, nope, they're not separate at all. They're woven together into a single four-dimensional fabric called space-time. You can think of it as the stage where the entire cosmic drama plays out. Now, for centuries, we thought of gravity as this mysterious force, like an invisible rope pulling things toward each other. But then Einstein came along with this truly revolutionary, mind-bending idea. He said, that's not what's happening at all. Instead, he said that massive objects actually bend and curve the very fabric of space-time around them. The classic way to picture it is to imagine space-time as a big stretched-out trampoline. If you put a heavy bowling ball, like a star, in the middle, it creates a deep curve. What we feel as gravity is just other smaller objects, like planets, rolling along that curve.
And this isn't just some cool thought experiment. It explains things we can actually go out and see. It's why planets travel in these elliptical orbits. They're just following the curve in space-time made by the sun. It explains why light from distant stars seems to bend as it passes by a huge galaxy. And it predicted that huge events, like two black holes colliding, would send out ripples in space-time, gravitational waves, which, incredibly, we have now actually detected. Which brings us right back home, back to us, these curious inhabitants on one small planet, just trying to piece together this unbelievably grand cosmic puzzle.
And we do it using these incredible tools. Giant telescopes sitting on mountaintops and sophisticated satellites orbiting way above our atmosphere, they're basically our cosmic time machines. They let us peer billions of light years away, seeing the light from stars and galaxies as they were at the very dawn of the universe. And every single new discovery, doesn't matter if it's a new planet or a faint ripple in space-time, it does more than just satisfy our curiosity. It helps us understand the fundamental rules of the cosmos. The exact same rules that allowed stars to forge new elements, that allowed Earth to form from dust, and for life itself to get started. So, we've just taken a lightning-fast tour of the universe, from the engines of stars all the way to the fabric of reality. We've started to learn the rules, but every answer we find just leads to bigger, deeper questions. The cosmic rulebook is vast, and our journey to understand it, it has only just begun. So, what will we discover next?